On lesson 86, we look at greater than and less than, trichotomy and transitive axioms, and irrational roots. So the trichotomy axiom over here just states that exactly one of the following is true. A is less than B, A is equal to B, or A is greater than B. So whenever we have the ones with the line through it where it is not either greater than, less than, or equal to, then it's going to be whatever's left, basically. And then the transitive axiom, if A is greater than B and B is greater than C, then A is greater than C. And then if A is less than B and B is less than C, then A must be less than C. Then our last one is if A equals B and B equals C, then A equals C. Okay, it just basically transfers to the next one because of this first rule. If this is true, then that's also going, and if this is true and this is true, then that must be true, is basically what it's saying. But I think it'll make more sense once we apply it to our examples. So on the first example, we're going to graph x is less than 3, and our domain is positive integers. So I'm going to put 3 on my number line. These are not going to be exact. And if x is less than 3, we have 2, 1, 0. Now positive integers, we're just going to put dots on the numbers because we do not want to include fractions. So it's just going to be 1 or 2 because of our domain. Okay, then let's look at the next example. Graph x is greater than -3 and our domain is the reals. So here we have our -3. And since the domain is the reals, we can shade to the right because it's greater than. Something happened. Right. We have an open circle and then we shade to the right. There we go. Alright. So again, open circle because it doesn't have the equal to sign, and then it is shaded to the right because it's greater than, and that is where the numbers get bigger or greater. Right? Now the next example, we have x is not, that's what that line means, less than or equal to -4. So if x is not less than or equal to, x must be greater than -4. And then we have our domain of negative integers. So I'm going to have -4 and -3, -2, -1, 0. Okay, x is greater than -4, and it's only negative integers. So again, we're just going to put dots on our negative integers because we do not want to include any fractions. And then that would be our graph. Alright? Now in the next one we have -x plus 4 is not greater than 2. So if it's not greater than 2, it must be less than or equal to 2. Then solve for x, so we'd have -x, we'd subtract the 4, so that's less than or equal to a -2, and divide by the negative, or multiply by the -1, either way. So we have a positive x is greater than or equal to a positive 2. So now we can place our 2 on our number line, and this is the reals, and it has the equal to sign, so we're going to have a solid circle, and we're going to shade to the right. Okay, alright. I don't know why my computer wants to reject the graph. I know they're not very good, but solid circle shaded to the right. Alright, if it disappears, I'm not going to put it back on. Then on example 5, we have negative x minus 4 is not greater than or equal to negative 2. So if it's not greater than or equal to, it must be less than negative 2. So we'll get the x by itself. So this is very similar to the other problem, just a different sign for our 4. So we're going to add the 4. So negative x is less than 2, and multiply or divide by negative 1. So x is greater than negative 2. So we'll put our negative 2 on our number line, and it's greater than, and we're looking at negative integers as our domain. So negative 1, 0. So really, the only one we have to include is that negative 1, because since it's integers, we don't want any fractions, so we just include the integers. Alright, then on the next one here, this is where we're going to have some irrational solutions, okay? So what I'm going to do first is get y by itself in this bottom equation. So y equals, I would add x to both sides, so it's going to be x plus 1. Then I'm going to fill that in for the y up here. So I have x squared plus x plus 1 squared equals 9. So I'll go ahead and square the x plus 1, so I'll have x squared plus x squared plus 2x plus 1 equals 9. Now I need to get my like terms together, and I also will need to move the 9 to the other side. So I would have 2x squared plus 2x and then minus 8. And that'll be equal to 0. Alright, then I would divide everything by 2 because that's a common factor, and that'll make the numbers a little bit smaller and easier to work with. So I'll have x squared plus x minus 4 equals 0. Alright, and now you could try to factor, but there's not going to be factors of negative 4 that give you a 1. So what that means is we have to use the quadratic formula. So x equals negative b, that's just a 1, so it's negative 1, plus or minus the square root of b squared, which is 1, minus 4 times a times c all over 2a. Okay, then we'll just simplify here. So x equals negative 1 plus or minus the square root, and this would be 1 plus 16, so that'd be 17, all over 2. Now I'm going to separate this into two terms. I'm going to have the x equals negative 1/2, and then plus the square root of 17 over 2, and then I'm going to have another set of two terms. That's just going to be considered one answer for x, and then I'll have negative 1/2 minus the square root of 17 over 2. Because I'm going to have to substitute these in separately to find my y, and I'm going to put them in for this x here. So I'll have y equals negative 1/2 plus the square root of 17 over 2 plus 1. Now I can combine that 1 with the negative 1/2. So that'll be y equals a positive 1/2 plus the square root of 17 over 2. Okay, so that y goes with the positive x here. So that would be considered one of our points. And then I substitute in the negative 1/2 minus the square root of 17 over 2. And really all that's going to do is change this sign. So it'll be y equals 1/2 minus the square root of 17 over 2. And that would go with this term here. So that's the x and that's the y for it. And you can list those out if that will help. So we have negative 1/2 plus the square root of 17 over 2 for x, and then a positive 1/2 plus the square root of 17 over 2 for the y. And then our second point would be negative 1/2 minus the square root of 17 over 2, and then a positive 1/2 minus the square root of 17 over 2. And that would be our 2 points that we needed. Hopefully this helps you. If you have any questions, feel free to email me or ask me in class.